Hello and good morning. Welcome to our session, MySQL hands-on session, how to import data from Amazon Web Services to MySQL HeatWave. My name is Mario Beck. I'm managing the solution engineering team of MySQL in Europe, Middle East, and Africa. And I will guide you through today's presentation and demonstration as well. If you do have any questions during the webinar, please ask these in the Q&A facility of Zoom. So if you enter questions in the Q&A, I will either address these immediately or at the end of the webinar, I might refer to the remaining open questions. Okay, let's get started. So we have this how-to sessions on MySQL HeatWave. There were many sessions before in the week before. Here you have the reference with the QR code or with a link to access the other training sessions as well, all roughly about 30 minutes long, from best practice, how to set up things, how to set up replication and other topics, and many more will follow. Today in this series, we will talk about migrating from Amazon Web Services to MySQL HeatWave. The first case we will take a look at is the simple migration. That is most likely the 80% case that happens all of the time. It's small data volume, downtime is not a topic, and then we will increase requirements from step to step. We have actually three flavors of the MySQL database service. There is that regular MySQL database service, fully managed MySQL instance on Oracle Cloud Infrastructure, OCI. And that's compatible with the MySQL 8 that you might use on-premise or in other clouds as well. The important thing with that is the up-to-date version with the latest security fixes. And of course, you get premier support from Oracle. Then we also have the high availability option. The main thing about that is it is with zero data loss. Even if the primary instance dies, all committed transactions will be recorded on the other service as well. No data loss in case of failover. That's not the case with competitor solutions in most cases. And the third flavor is the HeatWave add-on, where we have extreme performance benefits compared to regular MySQL or even compared to other OLAP optimized databases. That's really interesting if you do a lot of analytics queries in your database. For today's talk, it doesn't matter which flavor of MySQL you are using. You can switch between the three. Everything applies to all flavors of MySQL. The one tool that we're using for migration is MySQL Shell. We are doing a logical upgrade, a logical dump and a logical load of the data. In former days, people used to use MySQL dump for that. I strongly recommend no longer using MySQL dump because it's really slow and it's lacking many of the new features that we have in MySQL Shell that will help us moving data and improve performance and so on. You will see this. MySQL Shell is a scriptable client. It is the MySQL command line client on steroids, as we can say. It has the standard SQL mode. There's also a JavaScript mode and a Python mode. We have utilities embedded into the MySQL Shell. For example, a utility to check for server upgrades if you're switching from MySQL 5.7 to MySQL 8. We have parallel import. We have the dump utility. That's the one we are using for migration, and the dump load utility. So it's really a very powerful tool. It's great for scripting anything around MySQL, and it's extremely powerful. Please use MySQL Shell not just for the migration, use it as your day-to-day command line client instead of the regular MySQL command line client. By the way, we currently have a preview available for MySQL Shell for VS Code. So there's a plugin for VS Code from Oracle to integrate integrate MySQL Shell into VS Code, so you can run all of MySQL Shell features from VS Code directly. Okay, so if we want to run MySQL Shell, we need to have the server instance where we can run this, and the standard would be to have a virtual machine running in OCI and using that to run MySQL Shell. MySQL Shell will then connect to the instance on Amazon Web Services, read data, export data to some storage, in the default case, local storage. And then we can load that dump from that local storage or better options to the MySQL HeatWave instance that we have on Oracle Cloud. You can run MySQL shell on other servers as well, but be aware it makes no real sense to run MySQL shell on your laptop, because all data will go from the Amazon Web Services instance to your laptop, and from there, when loading the dump to the MySQL HeatWave instance, this means you have twice the wide area network hops, so the latency is much higher and the performance will not be nice. However, what you can do is run MySQL shell either on a VM on OCI or on a virtual machine in Amazon Web Services. Both cases offer similar performance, but the cost of a virtual machine in OCI is typically much lower. Regarding the network connectivity between the two cloud sites, there are several options. I will not dig into detail how to set up the networking between the two. There are several options. Pick whatever suits your case. The first one, and that's the simplest one that I use for the demo as well, is configuring Amazon Web Services security groups. So the public IP address of my virtual machine that I will use to run shell, I have entered that into the security group. So this is the only IP address that is allowed to connect to the MySQL port on the Amazon Web Services instance. That's the one option. You can create SSH tunnels between the two. You can create a tunnel via OpenVPN, or you can define a site-to-site VPN to really connect the VPC on Amazon side with the VCN on Oracle side and really have a unified network between the two. So multiple options depending on the use case. Is it just a one-time migration? Are you fine with exposing the MySQL port from the Amazon site to the internet? Or do you require an SSH tunnel? Pick whatever suits your case. Then we need to prepare a few steps so that the migration will work. The first one is we need to have that OCI compute instance. So we have to create that instance. Optionally, you can create that as an Amazon EC2 machine as well, but I will go with the case of running on OCI. This machine will run MySQL shell, so we have to install MySQL shell, obviously. On OCI, that's quite simple. It's a sudo yum install MySQL -shell. If you're doing the same on the EC2 instance, it's a bit more, it's not challenging. It's 2 steps instead of 1. So you download the shell package and you install the shell package. The reason for the difference is the standard MySQL or the standard Oracle repositories are not part of the EC2 instance. When you run the instance in OCI, a simple yum install is sufficient to get the MySQL shell package. So once we have shell installed, check your local storage. For the simple migration, we will just migrate everything to local storage on that virtual machine. So be aware that all the data will be stored in a logical dump that is compressed. So it's not expanding very much over the database size that you have in the instance. But if it's a gigabyte, you need a gigabyte of storage roughly on the virtual machine as well. Then one important thing, because that's not always the case, is your database, your source database, the Amazon site, already on MySQL 8 or not? If it's not on MySQL 8, so if it's on MySQL 5.7, which is the release before MySQL 8, we recommend to upgrade first and then migrate. However, it is possible to migrate from MySQL 5.7 to MySQL 8 in that step when migrating. And this is actually what I'm doing in this demo as well. So I have a MySQL 5.7 instance on Amazon Web Services, and I will migrate into MySQL 8 on Oracle Cloud. And again, there is a tool in MySQL shell, which is called check for server upgrade, or the upgrade checker. And we will use that tool to see is there anything we need to change before we are able to do that upgrade. And the 5th step of preparation is we need to install a new MySQL HeatWave instance on OCI, an empty instance where we can load the dump to. So let's do that as a demo before we really see the complex statement here. So let me first connect to the Amazon Web Services instance here. You see that that's the address. I'm logging into admin at RDS-1 to my instance via the public internet and using that with MySQL shell. And now you see in MySQL shell, I do have the JavaScript mode enabled at the moment. I can switch between the different modes with \SQL, \JavaScript, and \py for Python. Now I have a regular MySQL command line client, show databases. And you see we have two schemas that are not standard. It's employee and employees and fail employees, just to have some data for the migration. It's interesting to take a look at fail. So we have two tables here. Show create table foo. We have that table with the character set of UTF-8 that will play a role later when upgrading, and some data in that, some umlauts, and we also have a table old style. I have created that just to show the things when migrating. And this table is running on my ISAM engine. Definitely very old style. We stopped recommending using my ISAM many years ago, I think with MySQL 5.5 or 5.6. Since then, InnoDB is the default, but you never know. There are applications that still run on my ISAM, and this is something we need to consider. Okay, so we have some data on a MySQL instance, which is 5.7. We can check that as well. It's a 5.738. And now, first thing we are doing is we want to check that for upgrade. So what happens? Oops, I'm sorry. We have to go to the JavaScript mode for that. This is the automatic test. It's testing the instance that I'm connected to and testing if everything will work for that upgrade. So there's no usage of temporal types in my data. I have no conflicting names with new reserved keywords in MySQL 8. There is something that is a warning. I have used the UTF-8 MB3 character set. It's recommended to use the MB4 data set now, which is much more performant. So it's recommended to change that to UTF-8 MB4, but I can stay with the old character set as well, of course. It's the MySQL schema. Okay, that will be on UTF-8 MB4 anyway in MySQL 8, but it's also the table fail.foo and column T, which has a default character set of UTF-8. The other things, no problems. There's something with system variables that I need to check, and the new authentication plugin in MySQL 8. I don't want to dig into details of the upgrade process, but you see it's very simple to check if my existing 5.7 instance is good for migration or not. I do have a few warnings that I need to consider, but I can do the migration. So let's do the export of data. And for that, I'm using, again, the MySQL shell. I'm calling the utilities object with the method dump schemas. And I'm only dumping the schemas that contain my application data, which is the employees schema and the fail schema. Only these two should be migrated. We will not migrate the MySQL schema because that's different in MySQL 8 anyway, but that tool will also migrate things like triggers and so on. There are also options to migrate users separately without migrating the MySQL schema. So only migrate your data schemas. I will give it a name, which is migration dump here. That's the directory that will be created on my local machine with all the dump data. And I give it some options. So the option is threads 2. So do this in 2 parallel threads and dry run true. So don't do anything, just try. And then we see that, oh, migration dump already exists. So that was a mistake in preparation. Sorry for that. You see there's that directory. Now it's gone. So I will connect to my Amazon instance again and try the same statement once more. Okay, and we get a warning that the current user on the Amazon Web Services instance has not the right access rights to use the flush table with read logs, so it will have to use log tables. This means we will block the instance for that update, and that's something to consider. I will show you tricks to bypass that if this is a problem for you. And also, the dumped value of the GTID executor is not guaranteed to be consistent. That's something we need to consider if we want to use replication later on as well. For now, for the simple migration, it's not a problem. But there's one thing to consider. We want to move to Oracle Cloud, and there are limitations in the Oracle Cloud service because it's a managed service. And for that, there is a new option that we can set. It's the same statement again, util.dump schemas, but there's another option set, which is OCI MDS true. This means test everything if it's compatible with loading into an OCI MySQL database service. And with that, we get some errors. So the table fail.oldstyle uses the MyISAM storage engine. That is not supported in Oracle Cloud. We do not support the MyISAM storage engine for multiple reasons. It's not crash safe, it's not performant. We can't offer any true high availability with MyISAM. So it's not supported, full stop. However, it's quite easy. There is an option for InnoDB. So I can request that tables will automatically convert it to InnoDB storage engine. I will use that option later on. And the table fail.foo does not have a primary key. Technically, it's not required to have a primary key in MySQL database service. However, it is very strongly recommended. If you ever want to switch to a highly available instance later on, you need to have a primary key on every instance. Again, that's not a problem. We can automatically generate primary keys, hidden primary keys, so your application will not notice. But there is a primary key which we will use for high availability later on. So again, I can set an option to add the missing primary keys as a hidden column. And then there are errors which are all the same. I do have in the employee schema, I do have some views which are created with a definer or with a security invoker clause. And these impose a security risk. That's why we have to strip these definer clauses from stored procedures, from triggers, and so on. The security risk would be that we can inject some code that would be executed with the execution rights of administrative users. And that's, of course, in a managed service, that's not possible. That's something that would be a security risk. Again, there is an option to strip these invoker and definer rules so that the stored procedures become safe. So let's do the last but one version of our statement. Oops, sorry. Now we dump the schema's employees and fail. We call it migration dump. We test for OCI compatibility. And we have added these compatibility flags, force InnoDB, strip definer, and create invisible primary key. Again, 2 threads, dry run true. Now everything will work, but it's a dry run. So let's make the dry run false now and really export the data. And you see we have 2 threads dumping. At the end, it was only 1. I will discuss this later on. And now we have the data in our local file system. Now let's connect to the local instance on Oracle Cloud. You can do this either by exiting MySQL shell and logging in again, or with /c, admin add, and the IP address of the instance in Oracle Cloud. Show databases. Starting with /SQL means only the statement should be executed in the SQL mode. So you see this is a plain instance, nothing in here. And now we can use the corresponding command, utility load dump, and we give it the name migration dump. It's accessing the local storage on my MySQL shell machine again. And here you see we have a problem because the dump was generated on a MySQL 5.7 instance. Now we are importing to MySQL 8 instance. To allow that, you have to override the option ignore version, set that to true, and then we are able to load the MySQL 5.7 dump into MySQL 8. And now it's loading. I didn't give a thread option here. And now you see we are using 4 threads actually, which is a waste of resources and not really helping performance because my machine only has 2 threads available. It's a 1.0 CPU machine, a very small one. And after a few seconds, our data is loaded. Show databases. Here we have the fail and employee schema. Let's check the tables. Show create table old style. And you see it has been converted to engine equals InnoDB. And show create table foo. And here that had just a single column. We have now my row ID big int unsigned not null auto increment invisible. That's the invisible column that has been added as a primary key. It's defined as a primary key down here. So now my table has a primary key. Select star from foo. But you see that primary key is not visible. That column is not displayed, even in a select star statement. So I have my invisible primary key. Everything is compatible with MySQL 8, and I'm good to go now. Okay, and this is actually the statement that I put here, connecting with MySQL shell to the Amazon Web Services instance, and then running util.dump schemas, which are the schemas I want to export, give it a name, migration dump, OCI MDS to true, check compatibility with Oracle Cloud, that's strongly recommended, and then setting compatibility flags as necessary. In my case, it was force InnoDB, strip definers, and create invisible primary keys. There are other options that might be necessary or not necessary. You can omit these as well if you don't need these. If everything is on InnoDB, you don't need to set force InnoDB, obviously. Define the number of threads to run in parallel and dry run false. You can just omit dry run, then it's false anyway, that's the default. And loading data, we connected to the instance in Oracle Cloud and then loaded the dump with a name. And in my case, I needed to set ignore version true. That's not required if you're coming from MySQL 8 and going to MySQL 8, and threads equals to optional to influence performance. And we check the data, it's on the OCI instance now. That was the simple migration, low data volume, because I'm dumping everything to the local machine that is running MySQL shell. Now let's do a more complex case. A simple migration, but with large data volume. Now we are not storing the data into the virtual machine or the local disk of the virtual machine, but instead we tell shell to dump directly to object storage in Oracle Cloud. That's a storage that you can use indefinitely. You don't have to define a size. You're not limited by any volume size. You can just consume object storage. And then we can also load the instance data from that object storage again. So let's try this. What is the preparation steps? We have to have our compute instance. We need MySQL shell. As before, we no longer have to check local storage. We have no capacity limitations on object storage, so that's not important. We have to check if the source database is MySQL 8, run check for server upgrade if needed. We do not have to install an empty instance on OCI, an empty MySQL or HeatWave instance. That's an interesting point. We can load the data immediately when creating the instance, and that's what we want to do here. But there's another step we need to do, and that is prepare MySQL shell to access object storage. And for that, MySQL shell must be enabled to and allowed to access the API of Oracle Cloud. The first thing is we need to have that's step 6, we need to have a storage bucket available. You can create that in OCI in the menu, storage, object storage, and you create a bucket. I gave it the name AWS Migration. That's just the container that will include everything. Take a note of the bucket name that you've created and the namespace. It's listed on the, if you look into the OCI console, the namespace is listed. The name is given and you can copy it from there. And then we have to have a key pair for MySQL shell to be allowed to access Oracle Cloud resources. Either you generate the key pair with OpenSSL on a command line, that's one option, but the simpler one is actually to let Oracle Cloud generate that key pair. And you have to register that key, whether it's your self-created or the one that Oracle will generate for you. You have to add that key to your user profile in OCI. The function is called add API key, and this is where you can generate new keys or upload an existing public key, and you keep the private key on your instance, obviously. And then you have to create a file for MySQL shell. Actually, it's not for MySQL shell, it's for the Oracle command line client that you can also use to automate everything in Oracle Cloud. So this gives you the option to create every step that you would do in the console, also via shell script. I strongly recommend that you work with that because it helps in automating extremely. And that that file is called, it's in your home directory, .oci/config, and it contains your user OCID that you have to copy from your user definition, the fingerprint of the public key that you've uploaded, and the key file to the private key that is on your local machine, and the tenancy ID. And ideally, which region, then you no longer have to define the region. So with these files, with these variables set into the file home opc.oci/config, MySQL shell is able to access resources in Oracle Cloud. And now the export is the same as before. We do the util.dump schemas, which schemas we want to dump. We give it a name. I call it migration dump L for large, just to use a different name. We use the same options as before, but we add 2 more. O is bucket name, so object storage bucket name. I called that AWS migration, and object storage namespace. And that's the string that I copied after creating the bucket. And that's it. With these 2 options and the file that allows shell to access Oracle Cloud resources, everything will be dumped to the object storage in Oracle Cloud. And now, how would you load that data again? Of course, you can load that data via MySQL shell, but there's an easier way and a very attractive way. And this is when you're creating the new MySQL HeatWave instance, you can click on Advanced Options, Data Import, and select the object storage bucket. And the data from that bucket is automatically loaded into the instance when creating the instance. Let me show you that simple step in the live demo here. Let me first connect to the Amazon instance again. And then I'm dumping the schema into the object storage with OS namespace and OS bucket name. Okay, everything is transferred. And now I'm going to the Oracle Cloud Console. Logging into my cloud tenant in Oracle Cloud and checking data on the object storage. Here's my object storage. There's that bucket AWS migration that I've created before. And here we have a data migration dump L. Let's take a look into that. These are the files that have been created from the dump. And now let's create a new MySQL instance, database systems MySQL. I will create a new database system, give it a name. Oops. And I don't want to talk you through all of these options, just the one that's interesting, show advanced options down here, data import. And I can give the URL to my object storage, but it's easier to click on that link here and select the right bucket, AWS migration. And there's only one directory in there, that's migration dump L. And that's it. And if I create instance now and add all the other variables that I need to set for creating an instance, the data will be automatically loaded. There's one other way. If you already have the instance, if you want to load that data into an existing instance, there's another very interesting option, which I need to explain, but it's a bit tricky. Be careful with using that option. You can disable crash recovery for an existing instance. This means we will disable all safety features of that instance. No more InnoDB logging asset. We skip asset compliance. We no longer do binary logging. All of that is gone. And this makes improves performance very much. It's bad for safety. So if the instance crashes, you have no way of recovering the data. But it's very good for loading data because the speed is very much increased. This is what we do when you load the dump at instance creation as well. So you can disable that crash recovery. You see that here in that screenshot. When you look at the instance, there is an option to disable crash recovery. Then you use MySQL shell to dump to load the dump. Again, with the two options, OS bucket name and OS namespace, and then make sure, that's very important, that you enable crash recovery again. It's very important that your workloads have crash recovery enabled. So it's okay to switch it off for an import activity, but then switch on crash recovery again. The benefit is the loading will go most likely twice as fast. Some performance considerations. It's important to run MySQL shell either on EC2 or on an OCI VM, not anywhere else, to reduce the number of network hops. Set the number of threads. I just picked two. Use the number of vCPUs that your instance has on Amazon Web Services. That's the number of threads you can run on your database system. So shell will connect with that many threads to dump the data. If you're talking about the number of OCPUs, multiply that by 2, because an OCPU is a core, which has 2 threads. So in Oracle, we count only the cores. We call it OCPU, Oracle CPU unit. where Amazon counts threads, and one core with hyper-threading has 2 threads available. That's why there's that 2-to-1 ratio between vCPUs and OCPUs. We recommend to have the same CPU count on the shell instance that will do all the migration stuff as on the RDS instance or Aurora instance, and as on the MySQL HeatWave instance. And again, 1 OCPU equals 2 vCPUs on Amazon side. It's also a good idea to temporarily increase the CPU count for export and also for import maybe, because that data migration, if you have a huge load, will cost a lot of time. And if you can temporarily increase the performance of that system, that will be very beneficial for the migration time. All tables should have a primary key before you do the migration. I didn't do it before. I just asked Shell to add that primary key when loading data later on. But that is not good for performance because tables are split into chunks, and chunks are exported in parallel. But that only works if the table has a primary key. If your original database does not have primary keys in the table, we cannot do chunking. So we can only use one thread to export data. That's why it's good to have all the migration issues out of the way before do the migration. So have your primary keys in the table before doing the migration, if it's important, if you need high performance. And when loading data, you can either load that when you are creating the instance, or you disable crash recovery. That will make the loading of data much faster. There's also another option. You can import data already while the dump is still running. This means the dump is running for 3 hours, but after 10 minutes, you can already start the loading of the dump with the option wait dump timeout set to n seconds. And then the load utility will wait. If there's no more data in the object storage, it will wait for this number of seconds and wait if there's any more data coming. So you can load data while it is being exported. And then the total migration time is just a little bit longer than the dump time. If all of that is not enough, there is another option. We can add replication to the mix. For that, it is often a very good idea to create a read replica on the RDS Aurora side so that we are minimizing the impact during dump. We need to do the flush tables with read log or log tables, and that will influence ongoing activity on that server. So to avoid that, it's good to have a read replica. If this one is stopped with log tables, it's not a problem, and we are dumping from that read replica. Then do the migration as shown before. And then the idea would be to set up replication from RDS or Aurora into MySQL HeatWave. However, that's not very easy, unfortunately. Amazon Web Services writes data into the MySQL schema. There's a heartbeat table, for example, and there's a regular write into that MySQL schema. However, writing to the MySQL schema is not allowed in Oracle Cloud. Obviously, that's something for the management of the MySQL server. So users should not write to the MySQL schema. That is a problem that we need to overcome. Also, Amazon Web Services is replicating in mixed mode. So the binary log is written in some cases row-based and in some cases statement-based. For example, that heartbeat is always written statement-based. MySQL HeatWave, however, accepts incoming replications only for row-based events. So again, that heartbeat statement would kill our replication. And Amazon Web Services does not necessarily leverage global transaction IDs, which is the modern way of replicating in MySQL and which is required for replicating in MySQL HeatWave. So what's the solution to all of these? We have to run an intermediate server on an OCI virtual machine where we run MySQL in a self-managed way. And then we can apply replication filters. For example, that intermediate instance should have a replication filter set with -- replicate wild ignore tables equals MySQL.%. So no replication of any changes that happen to the MySQL schema. And this server has to add GTIDs to the relay log file. And this you can achieve that when setting up replication with a changed replication source to my Amazon instance. and set the flag assign GTIDs to anonymous transactions. And then this intermediate server will be clean, and this one can easily replicate into the MySQL HeatWave instance. We are working on overcoming these and making this much simpler than having that intermediate instance. But at the moment, that's the way of doing an online migration, really including replication. First doing the migration of data, then doing replication to get a minimized downtime for the migration of data. However, in most cases, just using MySQL, using MySQL dump, but using MySQL shell with multiple threads with the performance optimization that I mentioned before is totally sufficient to reduce the downtime from 5 hours to 40 minutes. And that was acceptable in most customer cases already. So that replication is really a very rare case that it's necessary, but it's possible. So as a summary, MySQL shell is the best tool for that migration. Use local storage or OCI object storage to put the migration data during the process. Local storage is good for small volume. If you have large volume of data, then use OCI object storage. Explore the different performance optimizations. There are many options available to improve performance of that. I mentioned the big ones already. If absolutely needed, you can add replication to minimize downtime. And then you can enjoy the most modern, most secure, and most performant MySQL service that is available on Oracle Cloud. Okay, one last bit of commercial. I want to advertise the upcoming HeatWave learning pills that we will present next week: how to import data from Google Cloud to MySQL HeatWave, then how to set up a LAMP stack, and how can you enable HeatWave for the existing MySQL workloads so that you can benefit from the high performance. So you're welcome to join again next week, or in 2 weeks and 3 weeks, each time at the same time on Friday morning. Okay, with that, thank you very much for joining today. Thanks for using Oracle Cloud and MySQL database service, and then hope to talk to you again. Bye-bye.